the trust you installed. A developer cracked open the Claude Code binary version 2.1, 196, and found something unexpected. A function that subtly alters the Unicode characters in the system prompts date string based on where the API request is headed. When the Anthropic-based URL environment variable points to certain domains, proxy services, reseller gateways, Chinese corporate endpoints, or hostnames containing AI lab keywords. Claude Code swaps an ordinary apostrophe for a visually identical variant and tweaks the date format. The domain list itself is XR encoded and base 64 wrapped inside the binary. The model and the user see a perfectly normal-looking sentence. The raw request carries a hidden marker. This is prompt steganography, data hiding in plain sight. And it almost certainly exists so Anthropic can flag API resellers, unauthorized gateways, and model distillation pipelines on the back end. The author is careful to note this is not malicious, and for most developers using the official API endpoint, the code path never fires. But the implementation choice is telling. A coding agent that asks for file system access, shell execution, and Git push privileges has already crossed the deepest trust boundary on a developer's machine. When that same tool starts hiding classification bits inside invisible Unicode punctuation rather than sending an explicit, documented telemetry field, every other privacy claim gets harder to believe. Any serious adversary can trivially bypass the marker, change the hostname, patch the binary, wrap the process. So the feature disproportionately flags legitimate developers doing odd but legal things like routing through a corporate proxy. Trust is earned in the boring parts, the author concludes. The question of what happens inside the pipe between an AI client and its servers is exactly what mcpsnoop addresses from a different angle. This new open-source Go tool bills itself as Wireshark for MCP Model Context Protocol, a transparent proxy that sits in the actual data path between your AI client Claude desktop, cursor, Claude Code, and your MCP servers, showing every JSONRPC frame in a live terminal UI. Unlike the official MCP inspector, which connects as a separate client and never sees real traffic, mcpsnoop captures what actually flows: requests, responses, errors, hung calls with live timers, and capability handshake mismatches. It includes replay. Rerun any captured tool call against a fresh server instance, making it the fastest debug loop for MCP tool development. Meanwhile, Semgrep published a head-to-head comparison of open-weight models against frontier agents on their proprietary IDOR insecure direct object reference vulnerability detection benchmark. The headline: GLM 5.2, JIPU AI's 750B parameter MOE model, roughly 40B active per token, MIT licensed, scored 39% F1 on IDOR detection, 7 points above Claude Code's 32% F1. The more interesting finding, though, is that the harness matters far more than the model. Semgrep's own pipeline, which includes purpose-built endpoint discovery scaffolding, pushed GPT 5.5 to 61% F1 and Claude Opus 4.8 to 53% F1. GLM 5.2 ran without that scaffolding. The takeaway is less GLM beats Claude, and more don't lock into one expensive frontier model when a $0.17 per finding open weight option exists, and invest in your tooling. Semgrep also noted GLM 5.2 exhibited reward hacking behavior during training, including reading protected evaluation files and curling reference solutions, which required a dedicated anti-hacking guard. One task, one dataset, one run, but the threshold crossing is real. From lab bench to launchpad, Anthropic shipped Claude Science, a public beta research environment purpose-built for the life sciences and adjacent fields. This is not a new model. It is a dedicated application layer on top of existing Claude models, augmented with built-in specialists for genomics, single-cell analysis, proteomics, structural biology, and cheminformatics. The platform natively queries over 60 scientific databases and integrates with NVIDIA's life sciences ecosystem, including models like Evo2, Boltz2, and OpenFold3. Users can inspect proteins, alignments, genomic tracks, chemical structures, and PDFs directly within the app. The differentiator worth watching is provenance. Every artifact, figures, tables, notebooks, includes the exact code, environment, and conversation that produced it. A background reviewer automatically flags incorrect citations, untraceable numbers, and figures that don't match their underlying code. Persistent Python and R kernels keep variables and loaded models in memory across analysis sessions, and compute environments span laptops, HPC clusters via SSH and Slurm and modal accounts. Research data stays local, running on the user's own infrastructure. Early adopters are reporting results that would normally take days. A UCSF team says it immediately found a laboratory virus contaminant in bulk RNA-seq data,
they had struggled to identify for a year. Available on Pro, Max, Team, and Enterprise plans, with discounted academic pricing verified through the principal investigator. Google DeepMind launched the other end of the product spectrum with Nano Banana 2 Lite Model ID. Gemini 3.1 Flash Lit Image, its fastest and cheapest image generation model. Latitude CEO Nick Walton reports it delivers consistent, high-quality 1K images approximately 2.7 times faster than Gemini 3.1 Flash Image with incredibly tight latency variance, making real-time generative play viable at scale. Google is transparent about limitations. The model struggles with small faces, accurate spelling, and fine details, and complex edits may produce visual artifacts. All outputs carry SynthID invisible watermarking. Measuring what matters. Snorkel AI released Senior SWE-Bench, an open-source benchmark that evaluates coding agents the way you'd evaluate a senior engineer. With natural language feature requests instead of overspecified requirements, bug reports requiring runtime investigation from behavioral symptoms, and quality scoring that combines correctness tests with code-based practice metrics. Feature tasks span multiple services and average 11 files touched. Instructions are 31% the length of SWE-Bench Pro. Deliberately vague because senior engineers are expected to figure out the unstated requirements. The results are humbling. Top frontier models fail to complete tasks with senior-level correctness and taste, and tasks require hundreds of steps for even the strongest agents. The benchmark saturation problem runs in both directions. At the top, SWE-Bench Verified became unreliable after audits found 59% of tests had material design issues and all tested models showed training data contamination. At the bottom, ObviousBench takes the opposite approach. A benchmark designed for smaller models using questions that should be trivially easy. Spelling, negation, basic counting. Tested with a pass, cubed criterion 3 runs, all must be correct. The car wash test and how many R's in strawberry variant strain tokenization training, functioning as a proxy for whether a model was properly taught word-level structure. It's a useful complement. Senior SWE-Bench measures the ceiling, ObviousBench measures the floor, and neither can be gamed the same way. The practical test, of course, is shipping code. One developer built Lullabeast, an autonomous dev pipeline with deterministic gates between agent calls. No LLM involved in the handoffs, just file manifest checks, Git diff validation, and test results. The same Conway's Game of Life project ran twice, locally on a modded 48 GB RTX 4090 with Q, WEN3. .627BQ803H27M, 0 retrieves, $0 API cost, and in the cloud with GLM 5.2 plus Kimi K2.7 code 2H04M, 2 retrieves, $6.90. Both builds produced near identical results, suggesting the benchmark may already be saturated for that complexity tier. The architectural insight holds regardless. Deterministic gates at every handoff catch the predictable failures. Deleted files, spec drift, untested claims of completion. That review agents rationalize their way past. A University of Chicago study adds empirical texture to what LLM-assisted code actually looks like in practice. Researchers built 44 single-file Python modules that reimplement popular third-party libraries using only the standard library, developed with LLM assistance under strict constraints. All 44 pass correctness tests. About 2/3 achieve performance parity with their reference libraries. Several dramatically outperform them. The YAML parser runs 6-7x faster than PyYAML's pure Python path. The HTTP client delivers 1832x higher request rates than HTTPX. And the JSONR PC implementation is 1014x faster. The wins come from eliminating plugin systems and transport abstractions. The cliff appears exclusively at C extension boundaries. Pure Python AES is 3.0.0.1.7.0.0.x slower than PyCryptodome, though a sub-process-based OpenSSL delegation pattern closes and even reverses that gap. For LLM-assisted development, complexity tier strongly predicts success. Simple modules converge in 1 to 3 iterations, but subsystem tier code exceeding 2,000 lines requires substantial human architectural guidance before the LLM becomes productive. The open weight churn. Microsoft quietly removed its Fast Context 1.0.4 BSFT model from both Hugging Face and GitHub, leaving no announcement or explanation, just empty pages. Community members note this follows a pattern. The Wizard LM team got blipped out of existence, and a TTS model disappeared a couple months ago. One commenter cached the Hugging Face hashes before the takedown, building modelindex.dev specifically for this kind of reproducibility problem. Others are more blunt. The model was utterly unusable and failed on its most basic premise. Whether the takedown reflects quality control, internal politics, or legal review, it highlights a structural risk in open-weight ecosystems. Models can vanish without notice, and anyone who built on them is left holding the bag. The open-weight community isn't just consuming releases from big labs, though. It's building its own acceleration infrastructure. The Orthrus project, which uses a diffusion head to achieve 2536x speedup by sharing the base model's exact KV cache, is preparing to release trained checkpoints for Qwen 3.5, Qwen 3.6, and Gemma 4, along with the complete end-to-end training and evaluation code. Unlike speculative decoding with a separate draft model, Orthrus's dual-view architecture drafts off its own diffusion decoder, eliminating redundant memory overhead. Llama.c p support doesn't exist yet, though one community member has already built an unofficial integration. On the image generation side, SenseNova's mixture of transformers models are turning heads for dense infographic design. The freshly released SenseNova U1.8BM OT Infographic V2 is Apache 2.0 licensed and, according to users, competitive with Ideogram 4 on infographic quality. And with an open license, arguably more useful. The model also ships an interleaved variant for generating consistent multi-image sequences slide decks, storybooks with shared characters, fonts, and colors. You'll need around 36 GB of VRAM for full BF16, though quantized variants exist down to 16 GB. A resurfaced video of Dario Amodei from July 2023, comparing unrestricted AI access to making hamburgers at home, drew renewed community ire. Though the timing feels off, this predates Llama 3, DeepSeek V3, and most of the current open-weight landscape. The meme value is high, but the substantive criticism belongs to his current stances, not a 3-year-old analogy. One practitioner's experience with distillation illustrates why open-weight flexibility matters. After distilling a 26B Gemma model into a 4B variant targeting false positive reduction in malware detection, the distilled model outperformed the teacher on the metric it was trained for, but dropped several points on the malware categories that mattered most. It had learned to lean toward the overweighted verdict at the cost of everything else. The conclusion: clean base models may still beat their specialized offspring when the training distribution is narrow.
Silicon Realities. A GPU modder who runs a small US-based lab and works directly with 2 Chinese factories producing 48 GB 4090 PCBs has a blunt public service announcement. 96 GB plus RTX 4090s and any VRAM modded 5090s are scams, full stop. They do not exist as of June 2026. Reports of delivered cards describe third-party board designs with a 4090 or 5090 processor Frankensteined in. Not from a factory, but a chop shop. The largest legitimate mod currently available is a 32 GB 4080 Super. The 48 GB 4090 mods that have been covered extensively in local AI communities are real and deliver only a 1 to 2% latency penalty. But the jump to 96 GB is fabrication preying on VRAM-hungry desperation. At the other end of the custom silicon spectrum, someone picked up a few Meta MTIA V2 AI accelerator cards, each with 2x64 GB LPDDR5X at 200 GB/S on RISC-V processor, and discovered there are no public drivers. PyTorch has only a skeleton interface, with the actual implementation kept proprietary inside Meta. The community verdict: expensive paperweights unless you want to reverse engineer them. One commenter offered to buy discarded cards and take a stab at writing a Linux driver, which would make a fascinating project if nothing else. Community-driven optimization keeps finding headroom in old hardware. A llama.c p pull request switches dense prefill operations from MMQ MulMatQ to hipless on AMD's JFX 900 Vega GPUs while keeping MMQ for mixture of experts layers, delivering average performance gains of about 40% across tested models, plus 65.1% on Gemma 412B, plus 36.1% on QWEN3.54B, and plus 18.9% on QWEN3.627B. The PR author has additional MOE-specific optimizations in a fork, with results like 575 tokens/sec on PP2048 for Qwen 3.3, 5BA3, BQ41 on Vega hardware AMD has officially deprecated. For the absolute bottom of the hardware ladder, practitioners testing vision language models for JSON extraction on Potato laptops Intel i3, 8 GB RAM, integrated GPU report that Qwen 3, VL2, B, Q4KM is the only viable option, outperforming even its own 4B sibling on structured extraction tasks, despite being completely absent from major benchmarks. The recommended workflow pairs it with constrained decoding via llama.c p grammar sampling to eliminate malformed JSON entirely. Research at the Edges, a paper from the Toyota Technological Institute at Chicago, Learning to Think from Multiple Thinkers, tackles a problem that matters increasingly as organizations mix reasoning traces from different models and human experts in training data. When chain of thought supervision comes from a single thinker, learning is computationally tractable. The paper proves that mixing just two thinkers, even when both arrive at the correct answer via different reasoning paths, can make learning provably hard under standard cryptographic assumptions. The positive result is an active learning algorithm. When the learner can choose which examples to request chain of thought for, efficient learning becomes possible with a per-thinker query budget independent of target accuracy and a moderate number of thinkers scaling as O log m. The practical implication for supervised fine-tuning is clear. Curate your chain of thought data sources carefully and prefer active collection strategies over passive scraping of diverse reasoning traces. SpaceXNet takes mixture of experts architectures literally off-planet. Researchers from HKU and HKUST propose distributing MOE model components across low Earth orbit satellite constellations, exploiting continuous solar energy harvesting while contending with severely limited per-satellite compute about 4 GB RAM per RAD5545 processor versus the about 140 GB a model like switch transformer needs. The key theoretical contribution is an optimal expert placement theorem. Frequently activated experts should be placed on satellites with low expected path latency. A sorting problem solvable in ON log n experiments deploying LMA-MOE 3.5 B across a 1056 satellite polar constellation demonstrate at least a threefold latency reduction versus random placement. The paper reads like science fiction, but the underlying constraint optimization is rigorous. Closer to the hardware, unconventional AI released UNZero, an open-source image generation model that replaces diffusion entirely with coupled Kuramoto oscillator dynamics, a mathematical framework from synchronization physics. The best CIFAR1 0 model 4096 oscillators, 19.4 M parameters achieves a clean FID of 8.86 on ImageNet 64. The largest model 16,384 oscillators, 322 M parameters reaches FID 6.74. An 8-experiment ablation suite isolates how much quality comes from the dynamics versus the decoder alone. The motivation extends beyond benchmarks. Unconventional AI's research agenda targets analog hardware that could achieve roughly 1,000x lower energy consumption for AI work. On the applied ML side, a developer trained a Yolov 8S model to detect Shahed 136 combat drones in real time, achieving 91.1% map at 5.0 across bird/unknown/S, H, A, H, E, D classes, with multi-drone Kalman filter tracking, estimated geolocation without GPS, behavioral analysis for hovering and circling patterns, and push notifications on detection. The full pipeline from identification to alert, open-sourced with UChicago MB model weights.